Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most dominant programming languages on the entire planet, Java. We're going to break down its core concepts piece by piece, so you can really understand how it runs basically everything, from massive company servers to the Android phone that's probably in your pocket right now. All right, let's get into it. You see, the entire reason Java took over the world comes down to this one simple but incredibly powerful promise: write once, run anywhere. This was a total game changer. The idea that you could write your code just one time and it would just work on a Windows PC, on a Mac, on a big Linux server, you name it. No changes needed. This single philosophy is the key to, well, everything else we're about to talk about.
Okay, but that raises a pretty big question, right? How on earth is that even possible? How can one language speak to so many different kinds of computers when they all have their own unique hardware and operating systems? It sounds a little like magic. The answer, though, isn't magic. It's just a really, really clever piece of engineering that acts like a universal translator.
And that translator has a name, the Java Virtual Machine, or what everyone just calls the JVM. The easiest way to think about the JVM is as a special program you install on your computer. Once it's on there, your machine, whether it's a Mac, a PC, whatever, suddenly knows how to speak Java. It creates this perfect, standardized little world, a virtual machine, where any Java program can run and feel right at home. Now let's see how all the pieces of the puzzle fit together, because this is a core concept that honestly trips a lot of people up. So at the very top, you've got the JDK, the Java Development Kit. This is the whole shebang, the complete toolbox for any developer. It has everything you need to write and build your programs. Now packed inside that toolbox is the JRE, the Java Runtime Environment. Think of the JRE as the workshop. It has everything you need to run a Java program that's already been built. And then inside that workshop, doing all the heavy lifting, is our master craftsman, the JVM. So simply put, the JDK holds the JRE, and the JRE holds the JVM. So now that we know the players involved, let's follow a single piece of code on its journey. We'll see how it goes from a simple text file on a developer's screen to a full-blown application running on your machine. This is where that run anywhere magic really happens. It all starts when a developer writes their code into a simple text file that ends in .java. Then they use a special tool from the JDK toolbox called the Java compiler, or Javac. And here is the absolutely crucial part. It doesn't translate the code directly into machine language for Windows or for Mac. Nope. Instead, it creates this special intermediate file that ends in .class. And then the JVM on your specific computer takes that .class file and does the final translation into the language your operating system can understand. And what do we call that special universal language inside the .class file? That's bytecode. This right here is the secret sauce. It's not for Windows, it's not for Mac. It is a language built specifically for the JVM. Any JVM on any device in the world knows how to read bytecode and make it work. This is how Java delivers on that famous promise. Okay, so we've totally nailed how Java runs anywhere. Now let's switch gears and talk about how you actually think and organize your code when you're building with Java. And that brings us to this huge idea called object-oriented programming, or OOP for short. It's all about modeling the real world with digital blueprints. In Java, that blueprint is called a class. Let me give you a really simple analogy. Imagine you have the architectural blueprint for a house. That blueprint defines everything, right? How many rooms, the size of the windows, and what you can do, like open the front door. But the blueprint itself, it's not a house. It's just the detailed plan for how to build one. In Java, a car class would be the blueprint defining things like color and speed, and what it can do, like drive. So if the class is the blueprint, then an object is the actual real-world house you build from that blueprint. You can use that one blueprint to build a whole neighborhood of different houses. A red one, a blue one, a big one, a small one. Each house is its own separate object, but they were all built from the same original plan. Same in Java. You can create a my red car object and a my blue car object, both from that single car class. Okay, let's take a quick technical detour here, because this detail is really important for understanding Java. While almost everything is an object, there are a few little exceptions, what we call primitive types. Things like int for a simple number, or boolean for a simple true or false. These aren't objects, they're just raw values. And this is the reason you'll hear people say Java is object-oriented, but not purely object-oriented. To get around this when we need an object, Java gives us wrapper classes, like integer, that literally wrap up that simple value into a full-fledged object for us. This whole philosophy of object-oriented programming is really built on four main ideas. We call them the four pillars, and these are the core principles that help developers write code that is way more secure, reusable, and just generally easier to manage. This table gives us a fantastic bird's eye view. We've got encapsulation, which is all about bundling things together securely, inheritance, which is a super powerful way to reuse code, polymorphism, which lets our objects be flexible and take on different forms, and abstraction, which is all about hiding the messy complexity. Now, let's just zoom in on the first two to really see how they work. So let's talk about encapsulation. The main idea here is to protect an object's important data from being changed randomly from the outside. The way we do this is by making its data fields private. So if you want to change a car object's speed, you can't just reach in and set it to whatever you want. Instead, you have to go through a public setter method. That method can then check the value first. For example, it can say, hey, a negative speed doesn't make any sense, and reject it. It basically bundles the data and the logic that protects it together safely inside a little capsule. Next up, inheritance. This one is a massive time saver. Let's say you've already built an animal class, and it has a method called eat. Now you want to create a dog class. Well, instead of writing the eat method all over again, you can just tell Java that your dog class extends the animal class. And just like that, boom, your dog class automatically knows how to eat. It inherits all the abilities of its parent. It's an incredibly powerful way to reuse code you've already perfected. So let's bring this all home. What are the big ideas you should walk away with? First, Java's power comes from that one core promise. Write once, run anywhere. That promise is made real by the JVM, which is our universal translator for that special language, bytecode. To manage all this code, Java uses object-oriented programming, where the central idea is the class as a blueprint and the object as the finished house. And finally, those key principles, the pillars of OOP, are the rules that help us use those blueprints to build amazing, secure, and efficient applications. So there you have it. We've covered the absolute foundations that made Java a global powerhouse. From the genius of the JVM to the core ideas of object-oriented programming, you now have the mental model for how it all clicks together. The only question left is, now that you know how this powerful tool works, what problem are you going to solve with it first? Thanks for joining this explainer.